the first one is, I don't know what my a complex number, right, is in the form a plus bi, where a is the real part and bi is the imaginary part. Well, you can graph complex numbers by just making the x-axis be the real axis and the y-axis is the imaginary axis. So if you graph, I don't know, 2 plus 3i, if you graph that on the real imaginary axis, you would just go 2 on the real axis and up 3 on the imaginary axis, and that would be the point 2, 3. It's helpful if you graph it, because then, just like everything that we do, we can talk about this in terms of an angle and in terms of a triangle, right? So if we just drew in from like here to here, right? We want to talk about the distance, right? The distance from the origin to that imaginary number graph. Just like with vectors, right? We talk about it as like distance, and they kind of put absolute value bars around it. It's positive. A vocab word for this is called the modulus. I don't think you ever really need to know that word unless you're going to be on the Jeopardy or something. But it's really just the hypotenuse of that triangle that you can form, just like we formed with vectors, just like we've done since the beginning of the semester with straight. So it's really just like the hypotenuse, I'm going to say that. Which means I'm just going to take the square root of, and again, if we're thinking x, y, and r, we would take the square root of x squared plus y squared, but we're going to call this the real part a and the imaginary part b. We're going to say that's the square root of a squared plus b. And usually, I think I have a couple cards. They don't. So some of this today isn't so bad, it's just kind of getting used to it. Again, talking about imaginary numbers. So look at the next line here, you can do this. Plot 4 minus 2i and find, that means find the distance there, or find the radius, or find the hypotenuse. So when you see that notation, you got to know that means like distance, not like the magnitude. When you label that point, that's just for -2. It's up to you if you want to draw a line in, or if you want to draw the triangle, you can. But that's the point. You just plot the point. So then to find this, right, if you didn't have to plot it, it's just knowing the formula. You're just taking this number squared plus this number squared. That's just 16 plus 4, which is the square root of 20, which again, usually they don't want you to do this one here. Right. So less groundwork to here to build like we did with vectors, but the idea is that we can take a complex number and we can talk about the angle and we can write it in trig form. So that's what we're going to do. So trig form of a complex number. I don't know why I drew the lines in here and not the rest of it, but let's just make a point over here. And let's just call that a complex number. I know over here quadrant 2 would actually be negative, but let's just generically say a plus bi, where a and b are the real part and the complex part. And so just like with vectors, you can draw that triangle in. And again, depending on where you are, sometimes it'll be negative, but this is always going to be your real part. That's going to be your A value, whether A is negative or positive. This is going to be your B value. And then this is our length or our radius of our. Okay, technically the angle is measured from 0 over, but remember that whole idea of reference angle? Like I can call that theta. Technically it's, I don't know what to say here. Technically theta is here. But we use that reference angle to go up. Before I play the unit circle, move a little bit. What would the cosine of theta be? It's like theta. Cosine would be x over r or a over r. Or if you solve that for a, just like we did for the vector part, then I say that's the same as r cosine of theta equals a. And for sine would be b over r. So that's the same as saying r sine of theta equals b. So for every every complex number of a plus bi, you could rewrite that in trig form by saying r cosine of theta plus, I always put the I in front, so I times r sine of theta. You could factor an r out of that. And you could say that's cosine theta plus I sine of theta. And you might say, why in the world would I ever want to do this? There's some things that that we can do and that we're going to do tomorrow with this that you'll see where this is helpful. Something that I had never seen before until I taught out of this book last year, and I talked to Mr. Allspaw about it, and he had never seen it before. And then after looking at our pre-cal book more, I found it in there as well. They simplify this more into another form, and it doesn't mean anything except for it simplifies it more. So they write it like this, R, and then they write CIS theta. That's the dumbest thing you've ever seen. But that stands for cosine I sine of theta. And the only reason I show you this is because on your quiz and on your test, the directions say write in R theta. I don't even know how to say that. CIN. I never used that ever until last year, but I think it's something that they've just simplified it down more. To me, this is the same, right? This is all worked out. That's just shorter to write. Because theta is going to be the same value in both of these, so it's just shorter to write that. This is the trig form of a complex number. So what we're going to practice today is just going from one form to the other, and then tomorrow I'm going to show you something that we can do. Trig form is also called polar form. There's some polar. Those are kind of interchangeable words. Okay, so my notes are kind of long, but I just kind of gave you read the one here. So the rest of these are just examples, and you're going to see how sometimes you don't have to do a lot of work. Other times you might have to do some work. Sometimes they're going to be really nice angles that you get from the circle. Sometimes they're going to be ugly angles that you have to use a calculator for. So I just try to pick some examples here for you. So write in trig form. So I'm going to kind of use some work here to show you. If I graph this, okay, that would be right there. If I want to write this in trig form, I want to end up so that I have R, whatever, CIS of theta. make myself like that. It is shorter. That's where I should end up, which means I need to find r and I need to find theta. R is really easy to find, right? 2, 2. This is 2 and this is 2, so you can solve for r. If you know r off the top of your head because you know your special triangles, but if not, r is just going to equal the square root of 2 squared plus 2 squared, which is the square root of 8, which is 2 radical 2. So remember, if you have an isosceles right triangle, the ratio of the sides are x, right, 2. So that's what that's 2 radical 2. The second thing you need is theta. And again, sometimes you're going to be able to tell what theta is by looking at it. If I go over 2 and up 2, right, do you know what angle I'm at on that picture right there? Or if you know what kind of triangle I've drawn in there, since it's an isosceles right triangle. It's just 45 degrees. It's right there in the middle. But if you didn't know that, all you have to do is set up sine, cosine, or tangent. It doesn't matter. It's your choice. Right? Here's my theta. I know this is 2 radical 2. Sine, cosine, tangent. If I set up tangent of this, tangent of theta would equal 2 over 2. Tangent of theta equals 1. What angle in the first quadrant has a tangent of 1? It's pi force or 45 degrees. Usually the directions will tell you, I think, whether to use degrees or radians. I always use radians. So to write a complex number in trig form, all you have to have is r and theta, and I'm going to write it out fully, and then I'll write the shortened version. So r cosine of theta plus I sine of theta would just be 2 radical 2 times my cosine of pi force plus I sine of pi force. Those of you that took pre-cal with me last year, we did this. We didn't do this cis form, which you can see is shorter, right? Because all you have to do is write cosine, actually not for cosine, I sine, and then you could just say I. And that's okay, right? And again, if you can tell what r and theta are without doing all the work, again, you don't always have to do a ton of work. If I graph the complex number 4i, that means 0 on the real axis and 4i on the imaginary. 4 up, that's just up 4, right? So that would just be right there. So again, I could do a lot of work. I could solve for r and I could solve for theta. But if you graph that, what is the angle going to be if I'm up there on the y-axis? Yeah, so I can tell that theta is pi half without having to set up the problem I can pick up if I want. And the length from the origin to that point, do I need to do Pythagorean theorem to do that? No, because if it's a vertical line, I can just say that I'm up 4 units from this point. And so it's really nice when it's on the x or the y-axis. You don't have to do all the work to get there. You can just write your answer, which I'm going to go the book way here and just say 4 EIS of pi half. And if you work that out, you get back the figure. All right. So I did 2 of these, right? I did this one. This is from my 3-cal notes where I said go back in standard form, which means standard form is I want you to write it in A plus BI form. Same idea is if they gave it to you like this, you need to be able to go backwards. So it's much easier if it's spelled out like this, because you just actually work it out. So is 225 degrees from my unit circle? It is. So if it's from the unit circle, it means I don't want decimals. 225, that's just down here, right? Which would be negative square root of 2 over 2, negative square root of 2 over 2. So I'm just going to work this out and say 1/4 times negative square root of 2 over 2. And I'm just going to go ahead and distribute that 1/4 if you're okay with that. Plus I times 1/4 times negative square root of 2 over 2. I'm just going to go ahead and distribute that 1/4 in there as I replace sine and cosine with what they equal. And then you just have to make sure you simplify it correctly. There's not much to simplify here. Nothing cancels out. That would just be negative square root of 2 over 8 minus square root of 2 over 8 with an I somewhere in there. So standard form is just breaking it back up as A plus BI. If they give it to you in their simplified form, which is what they're going to give it to you in, you have to know what that stands for. Cosine, I sine of 49 degrees. 49 degrees is not in my unit circle, which means you can give me decimals on this. But this is the same as if I would say the square root of 34 times cosine of 49 degrees plus I sine of 49 degrees. So you have to kind of know what that CIS stands for. And then you're just going to take the square root of 34 times cosine of 49. Square root of 34 is gross. Cosine of 49 is gross. So we're just going to go a decimal here. Square root of 34 times the cosine of 49 degrees. I get about 3.83. And then don't forget your I on this one. You get about 4.4. And you can always see if your answer at least makes sense. Square root of 34 would be your radius. 49 degrees is in quadrant 1, and so it makes sense that A and B are both positive, because that would get you in quadrant 1. Again, we're going to look at some other stuff tomorrow. Simplifying some equations, solving, multiplying. We don't go into this as much as we go into it in 3-cal, which means we don't get to do the Morse theorem and finding complex roots. That annoys me, because to me that's the whole point of doing this. Because otherwise, why do you need to do the trick form of it? But they don't make you do that, so we're not going to do that. So we do for you. So you do have a few more problems today than you've had in the past, because they're not that bad. Like they're not like parts A through B. A through B. So 24 through 33, you're just finding the link, you're graphing some of them, you're writing it trick form. And then 48 through 54 are like our last 3 examples where it's in trick form and you're taking it up to complex.